Impact Report, projected 50% increase in aerospace workforce and implications for engineering, manufacturing and robotics industries by Q4 2025. Date, January 25, 2025. Executive Summary. The aerospace workforce is projected to increase by 50% by Q4 2025, driven by technological advancements, rising demand for skilled labor, and evolving market dynamics. This growth poses both opportunities and challenges across the engineering, manufacturing, and robotics sectors. Companies will need to adapt to manage talent shortages, invest in technology and digital infrastructure, enhance supply chain resilience, and prioritize sustainability initiatives. Key trends and implications. 1. Talent shortages and workforce development. The aerospace sector's growth highlights existing talent shortages, with nearly 60% of manufacturers struggling to attract and retain skilled workers. By 2030, it's estimated that 1.9 million manufacturing jobs may remain unfilled if current trends continue. Companies will need to focus on robust workforce development strategies, including training and upskilling initiatives, to address these gaps. 2. Investment in technology and digital infrastructure. The manufacturing sector is prioritizing investments in digital technologies, particularly AI and machine learning. As of late 2024, 55% of industrial manufacturers were utilizing generative AI to enhance productivity. This trend is expected to accelerate, supporting optimized design and manufacturing processes in aerospace. 3. Robotics and automation. The integration of robotics within manufacturing operations is set to transform productivity levels. The rise of autonomous mobile robots AMRs and collaborative robots cobots will redefine workforce dynamics by enabling complex task execution, enhancing operational efficiency, and allowing seamless human-robot interaction. 4. Supply chain resilience and efficiency. Despite improvements since the pandemic, supply chain challenges persist, driven by geopolitical tensions and rising costs. Manufacturers will need to adopt agile strategies, diversify sourcing, and invest in digital tools to enhance planning and visibility, ensuring they can meet increased production demands in aerospace. 5. Sustainability initiatives. The aerospace industry is increasingly focusing on sustainable practices in response to regulatory pressures and consumer demand. Companies are investing in electrification and emissions reduction initiatives, though they must balance profitability with environmental goals. Timeline of events and future outlook. 2024, manufacturing sectors stabilize with investments in clean technology and digital infrastructure, but talent acquisition challenges persist. Q4 2025, a projected 50% increase in the aerospace workforce may exacerbate existing talent shortages, necessitating significant investments in training and technology. Beyond 2025, continued integration of AI and robotics will reshape operational efficiencies, with sustainability remaining a critical focus. Conclusion. The anticipated growth of the aerospace workforce by 2025 presents a catalyst for change within engineering, manufacturing, and robotics industries. Organizations must prioritize workforce development, technological investment, and supply chain enhancements to thrive amid evolving market dynamics. While challenges such as talent shortages and supply chain disruptions remain, opportunities for growth and innovation abound in the shift toward automation and sustainability. In-depth analysis. 1. Talent shortages and workforce development. The aerospace industry's rapid growth is projected to intensify existing talent shortages. The National Association of Manufacturers (NAM) reports that almost 60% of manufacturers face difficulties in attracting and retaining employees. The anticipated increase in the aerospace workforce necessitates urgent action from employers to enhance recruitment and retention strategies. As the demand for skilled labor escalates, companies are likely to invest heavily in workforce development programs. Efforts may include partnerships with educational institutions to create specialized training programs, internships, and apprenticeship opportunities tailored towards aerospace engineering and manufacturing skills. Emphasis on soft skills alongside technical training will be essential to prepare workers for collaborative environments that increasingly feature robotics and automation. 2. Investment in technology and digital infrastructure. Technological advancements are at the forefront of the aerospace workforce expansion. As manufacturers increasingly turn to AI and machine learning, the integration of these technologies will be pivotal in enhancing productivity. A Deloitte report indicates that 55% of industrial manufacturers are already utilizing generative AI, with growth expected to continue into 2025. Investment in digital infrastructure will enable aerospace manufacturers to optimize design and manufacturing processes. Technologies such as cloud computing, big data analytics, and IoT will create a more interconnected and efficient production environment. Companies must also focus on data quality and management to facilitate the successful implementation of AI-driven solutions. 3. Robotics and automation. The integration of robotics in manufacturing is set to redefine operational capabilities within the aerospace sector. The rise of autonomous mobile robots AMRs and collaborative robots cobots will enhance efficiency and precision in manufacturing processes. In 2025, cobots are expected to become more autonomous, capable of performing complex tasks and adapting to real-time changes in their environment. The ability of robots to learn from interactions will transform workforce dynamics, allowing human workers to focus on higher-value tasks while robots handle repetitive or hazardous activities. This shift will not only increase productivity but also improve workplace safety. 4. Supply chain resilience and efficiency. Despite recent improvements in supply chain conditions, ongoing risks remain due to geopolitical tensions and fluctuating costs. Manufacturers are expected to face challenges in 2025, prompting them to adopt agile supply chain strategies. This includes diversifying suppliers, investing in digital tools for better planning, and enhancing visibility throughout the supply chain. The aerospace industry's growth will demand robust supply chain management, requiring companies to anticipate potential disruptions and respond swiftly. Strategies such as nearshoring and building local partnerships may become more prevalent as firms seek to mitigate risks associated with global supply chains. 5. Sustainability initiatives. Sustainability is a core focus for the aerospace sector in light of increasing regulatory pressures and consumer expectations for environmentally friendly practices. Companies are expected to invest in clean technology manufacturing, emphasizing the electrification of aircraft and the reduction of emissions. However, balancing the costs of sustainability initiatives with profitability will be a challenge. Firms may need to navigate the complexities of government incentives, changing consumer preferences, and the inherent costs associated with transitioning to greener technologies. Future outlook. As we move into 2025 and beyond, the aerospace workforce's projected growth will catalyze significant changes across engineering, manufacturing, and robotics industries. Organizations must remain agile, adapting their strategies to meet evolving demands while focusing on workforce development, technological investment, and sustainability. By harnessing the potential of AI, robotics, and digital infrastructure, companies can position themselves for success in an increasingly competitive landscape. The journey ahead is fraught with challenges, but the opportunities for innovation and growth are equally compelling. This report underscores the critical importance of proactive strategies in addressing the upcoming shifts within the aerospace workforce and related industries. As companies prepare for these changes, a focus on collaboration, technological advancement, and sustainable practices will be essential for thriving in the future landscape. The projected 50% increase in the aerospace workforce by Q4 2025 signals profound implications for the engineering, manufacturing, and robotics sectors. As the aerospace industry gears up for this expansion, several counterintuitive insights emerge from the anticipated changes and trends. 1. Talent shortages amid workforce expansion. Despite the increase in workforce numbers, the aerospace sector is likely to face exacerbated talent shortages. The forecast suggests that while the overall workforce is growing, the demand for skilled labor will outpace supply. Nearly 60% of manufacturers already report difficulties in attracting and retaining talent, and a projected 1.9 million manufacturing jobs could remain unfilled by 2030 if current trends continue. This paradox highlights a critical need for companies to invest heavily in workforce development initiatives such as training and upskilling, rather than solely relying on increasing headcount. 2. Investment in technology as a double-edged sword. While the adoption of digital technologies like AI and machine learning is expected to enhance productivity, there's a counterintuitive risk that these same technologies may lead to further job displacement in the long term. Although these technologies can optimize operations and improve efficiency, they also require a workforce adept at managing and integrating these systems. Thus, while companies are likely to invest in advanced technologies, they must also prepare for a workforce that can adapt to these changes, creating a tension between automation and employment. 3. Robotics and human collaboration. The integration of robotics in manufacturing is set to redefine workforce dynamics. While the rise of autonomous mobile robots and collaborative robots cobots is anticipated to improve productivity, there is a nuanced understanding that these technologies will not replace human workers but rather augment their roles. The expectation is that cobots will work alongside humans, requiring a shift in skills and training rather than a straightforward reduction in the workforce. This shift may create an environment where human skills and robot capabilities are intertwined, leading to new job definitions and requirements. 4. Supply chain resilience versus efficiency. As manufacturers strive for supply chain resilience, the push for efficiency may yield unexpected consequences. While companies are diversifying sources and investing in digital tools for better planning, the complexities of geopolitical tensions and rising costs may render these efforts insufficient. The expectation that enhanced supply chain strategies will automatically lead to reduced costs and improved efficiency is challenged by the reality of ongoing market volatility. This suggests that manufacturers may need to balance their strategies with a degree of flexibility, rather than expecting a linear improvement in supply chain performance. 5. Sustainability as a profitability challenge. The focus on sustainability initiatives, particularly in clean technology manufacturing, presents a paradox where profitability may conflict with environmental goals. The shift towards electrification and reduced emissions is driven by regulatory pressures and consumer demand. However, the associated costs may challenge firms' profitability. Companies are likely to face the conundrum of needing to invest in sustainable practices while simultaneously managing the financial implications of such investments. The expectation that sustainability will lead to immediate financial benefits is countered by the reality that these initiatives require significant upfront costs and long-term strategies. 6. Economic conditions versus workforce demand. The forecasted economic conditions for 2025, including lower interest rates and potential increases in manufacturing demand, may seem to suggest a favorable environment for workforce growth. However, this expectation is tempered by the reality of labor market tightness. As demand for manufactured goods increases, the existing labor shortages could intensify, leading to greater competition for skilled workers. This dynamic underscores the notion that an improving economic climate does not necessarily translate to a readily available workforce, necessitating proactive talent management and investment strategies. 7. Clean technology investments under scrutiny. The anticipated investments in clean technology are expected to continue, yet firms may adopt a cautious approach due to the economic uncertainties ahead. This paradox arises from the dual pressures of maintaining profitability while adhering to environmental standards. Companies may find themselves in a position where they are compelled to invest in sustainability initiatives but are simultaneously wary of the potential financial ramifications of these investments. The expectation that clean technology will seamlessly integrate into existing operations without significant disruption is overly simplistic given the complexities involved. In conclusion, the projected increase in the aerospace workforce by Q4 2025 is not merely a straightforward narrative of growth, it brings with it a multitude of counterintuitive challenges and insights. The interplay between workforce expansion and talent shortages, technology adoption and job displacement, supply chain resilience and efficiency, and sustainability versus profitability presents a complex landscape that industry leaders must navigate carefully. As the aerospace sector evolves, the need for strategic foresight, adaptability, and a balanced approach to investment and workforce development will be paramount in addressing these emerging contradictions. The report on the projected 50% increase in the aerospace workforce by Q4 2025 highlights several critical implications for the engineering, manufacturing, and robotics industries. Among the various insights presented, certain aspects may be overlooked by many readers yet harbor significant implications for future industry trajectories. 1. Urgency of workforce development. While the report mentions talent shortages and the need for workforce development, it does not adequately emphasize the long-term implications of these shortages on industry innovation and competitiveness. The projected increase in the aerospace workforce is not merely about filling roles but about ensuring that these new employees are equipped with the right skills to drive technological advancement. The impending skills gap could hinder the industry's ability to innovate, especially as companies increasingly rely on advanced technologies such as AI and robotics. Significance: a workforce that lacks the necessary skills to operate and integrate new technologies may lead to stagnation in technological advancement, reducing the competitive edge of companies in the aerospace sector. This could have cascading effects on the entire supply chain, resulting in delays in project timelines and increased costs. 2. Investment in digital infrastructure. The report indicates that 55% of industrial manufacturers were already utilizing generative AI as of late 2024. Yet it glosses over the implications of this adoption. The shift towards digital transformation is not just a trend, it represents a fundamental change in how industries operate. The integration of AI and machine learning technologies can significantly enhance productivity, but it also requires a robust digital infrastructure that many companies may not yet possess. Significance: companies that fail to invest in the necessary digital infrastructure may find themselves at a disadvantage, unable to leverage the full potential of AI. This could lead to inefficiencies and increased operational costs, ultimately affecting profitability and market position. 3. Evolution of robotics and automation. The anticipated surge in robotics and automation, while mentioned, deserves deeper exploration. The report predicts significant adoption of autonomous mobile robots and collaborative robots, cobots. Yet it does not address the implications of this shift on workforce dynamics and job roles. The integration of such technologies may lead to a redefinition of job functions, requiring workers to adapt to new roles that emphasize oversight and interaction with robotic systems. Significance: understanding how these changes will affect employment patterns is crucial. Companies need to prepare their workforce for these transitions through retraining and upskilling programs. Failure to do so could result in resistance from employees and difficulties in effectively implementing new technologies. 4. Supply chain resilience. The report mentions ongoing supply chain challenges but does not delve into how these challenges may be exacerbated by the increase in workforce demands. The aerospace sector's growth will require robust supply chain management to meet production demands. Yet geopolitical tensions and rising costs could complicate these efforts. Significance: a failure to recognize and address these complexities can lead to production delays and increased operational costs, which can be particularly detrimental in the highly competitive aerospace industry. Companies must proactively develop strategies that enhance supply chain agility to navigate these risks effectively. 5. Sustainability initiatives. While the report touches on sustainability, it fails to emphasize the urgency of transitioning towards clean technology manufacturing. The aerospace sector is under increasing pressure to adopt sustainable practices, yet the balance between profitability and environmental responsibility remains delicate. Significance: companies that do not prioritize sustainability may face regulatory repercussions and reputational damage impacting their market viability. As consumer demand for sustainable practices grows, businesses must integrate these considerations into their operational strategies to remain competitive. 6. Balancing technology with human elements. The report hints at the importance of enhancing worker experiences and leveraging digital tools for talent planning and management. However, it does not sufficiently explore how maintaining a human-centric approach in an increasingly automated environment is crucial for retaining talent and fostering innovation. Significance: companies that focus solely on technological advancements without considering the human element risk alienating their workforce. A balanced approach that values employee input and experiences can drive engagement and productivity, ultimately supporting technological integration. Conclusion: the anticipated increase in the aerospace workforce by Q4 2025 is not just a statistic, it represents a critical juncture for the engineering, manufacturing, and robotics industries. While the report outlines several key trends and implications, the significance of workforce development, digital infrastructure investment, robotics integration, supply chain resilience, sustainability, and maintaining a human-centric approach cannot be overstated. Addressing these areas proactively will be essential for companies wishing to leverage the upcoming workforce expansion to enhance innovation, efficiency, and competitiveness in the evolving landscape. 1. Talent shortages and workforce development. The anticipated 50% increase in the aerospace workforce by Q4 2025 highlights a critical issue: talent shortages in engineering and manufacturing sectors. With nearly 60% of manufacturers already facing challenges in attracting and retaining skilled labor, the influx of new hires could exacerbate these difficulties. By 2030, projections indicate that 1.9 million manufacturing jobs may remain unfilled unless proactive measures are taken. This situation necessitates significant investments in workforce development, including upskilling initiatives and improved recruitment strategies. Companies must cultivate a pipeline of talent that is not only technically proficient but also well-versed in emerging technologies, ensuring they can meet the demands of a rapidly evolving aerospace sector. 2. Investment in technology and digital infrastructure. The aerospace industry's growth coincides with an increasing emphasis on technology and digital infrastructure in manufacturing. Currently, over 55% of industrial manufacturers are utilizing generative AI, with expectations for its adoption to rise. This technological investment is not merely about enhancing productivity, it also involves optimizing design and manufacturing processes, ultimately driving innovation. Furthermore, companies that prioritize a robust digital foundation are better positioned to navigate challenges such as higher operational costs and supply chain disruptions. The integration of AI and machine learning will be pivotal in reshaping operational efficiencies and enabling manufacturers to maintain a competitive edge in a global marketplace. 3. Robotics and automation. The rise of robotics and automation is set to redefine the operational landscape of manufacturing, particularly in aerospace. The increasing deployment of autonomous mobile robots and collaborative robots cobots will enhance productivity and efficiency, allowing manufacturers to streamline processes and reduce labor costs. The continuous advancement in robotics technology, characterized by improved autonomy and enhanced connectivity, means that human-robot collaboration will become more prevalent. This evolution will transform workforce dynamics, requiring workers to adapt to new roles that leverage these technologies. As automation becomes more sophisticated, manufacturers must ensure that their workforce is equipped with the necessary skills to work alongside advanced robotic systems. 4. Supply chain resilience and efficiency. Despite improvements in supply chain conditions post-pandemic, ongoing challenges remain, particularly as geopolitical tensions and rising costs could disrupt the aerospace supply chain. Manufacturers must adopt strategies to enhance supply chain agility, including diversifying sources and investing in digital tools that provide better planning and visibility. The anticipated growth of the aerospace workforce amplifies the need for robust supply chain management practices to meet increased production demands. As companies navigate these complexities, a focus on supply chain resilience will be essential for maintaining operational efficiency and meeting customer expectations in a competitive market. In conclusion, the projected increase in the aerospace workforce by 2025 presents both opportunities and challenges. The focus on talent development, investment in technology, the integration of robotics, and enhancing supply chain resilience will be crucial for the engineering, manufacturing, and robotics industries to thrive in the evolving landscape. Each of these points requires in-depth analysis and discussion to understand their implications fully and to strategize effective responses. 1. The Industrial Revolution, 18th to 19th century. The Industrial Revolution marked a significant turning point in history, as it transitioned economies from agrarian to industrial. The introduction of machinery drastically increased production capacity and efficiency, leading to a surge in the manufacturing workforce. This transformation necessitated the development of new skills and training to accommodate the changing landscape of work. Much like the projected increase in the aerospace workforce will require enhanced workforce development strategies today. 2. Post-World War II aerospace boom, 1945-1960s. After World War II, the aerospace industry experienced rapid growth due to technological advancements and increased demand for air travel and military aircraft. This boom led to substantial investments in engineering, manufacturing, and workforce training as companies sought to meet the new demands of the aviation market. Similar to the current projections, this period was characterized by a significant increase in the workforce and the need for skilled labor across various sectors within aerospace. 3. The rise of automation in manufacturing, late 20th century. In the latter half of the 20th century, the advent of automation and robotics transformed manufacturing processes. Companies began integrating robotics systems to enhance productivity and efficiency while addressing labor shortages. The shift not only revolutionized the manufacturing landscape but also highlighted the importance of workforce training and adaptation to new technologies, paralleling the anticipated impact of robotics and automation in the aerospace sector by 2025. The projected 50% increase in the aerospace workforce by Q4 2025 is set to significantly impact the engineering, manufacturing, and robotics industries. This transformation is driven by technological advancements, a surge in demand for skilled labor, and changing market dynamics, which will necessitate strategic adaptations across sectors. Key predictions and implications. 1. Talent shortages and workforce development. The aerospace sector's growth will intensify existing talent shortages. As reported by Deloitte, nearly 60% of manufacturers face difficulties in attracting and retaining skilled workers. By 2030, up to 1.9 million manufacturing roles could remain unfilled if these challenges are not addressed. Companies will need to invest heavily in training and upskilling initiatives to meet the rising demand for skilled labor. 2. Investment in technology and digital infrastructure. The aerospace industry will see accelerated investments in digital technologies, particularly AI and machine learning. As of late 2024, 55% of industrial manufacturers were already utilizing generative AI. This momentum is expected to continue, enhancing operational efficiency and productivity. Companies will leverage AI to optimize design and manufacturing processes, thereby reducing costs and improving competitiveness. 3. Integration of robotics and automation. The integration of robotics in manufacturing will markedly transform operations. There will be a notable increase in autonomous mobile robots AMRs and collaborative robots cobots that enhance productivity in aerospace and manufacturing sectors. Enhanced autonomy and improved connectivity in robotic systems will allow for more complex task execution and better collaboration with human workers, reshaping workforce dynamics. 4. Supply chain resilience and efficiency. While supply chain conditions have improved since the pandemic, challenges persist. The aerospace industry's growth will require robust supply chain management to fulfill increased production demands. Companies are likely to adopt strategies that diversify supply sources and invest in digital tools for better planning and visibility, particularly in light of ongoing geopolitical tensions and rising costs. 5. Sustainability initiatives. The aerospace sector is expected to increasingly focus on sustainability. Responding to regulatory pressures and consumer demand for eco-friendly practices. Investments in electrification and emission reductions will continue as firms strive to balance profitability with environmental goals. Companies will face the challenge of navigating the costs associated with these sustainable initiatives while maintaining competitiveness. Timeline of key developments. 2024, the manufacturing sector stabilizes with a focus on investing in clean technology and digital infrastructure amid ongoing talent acquisition challenges. Q4 2025, the aerospace workforce is projected to increase by 50%. This growth will necessitate significant investments in workforce development and technology. Beyond 2025, the continued integration of AI and robotics will redefine operational efficiencies in aerospace and manufacturing, with sustainability remaining a critical focus. Robotics trends in 2025. As the aerospace workforce expands, the robotics industry is expected to evolve alongside it. Key trends in robotics by 2025 include: enhanced autonomy, robots will achieve higher levels of autonomy. Capable of complex decision-making and real-time adaptation to environmental changes. Collaborative robots cobots. The demand for cobots will grow as their ability to work alongside human operators enhances efficiency and safety in dynamic environments. Mobile manipulators. These robots will play a significant role in transporting and handling materials, optimizing operational efficiency in various industries. Digital twin technology. Virtual simulations will allow companies to optimize robotic processes, reduce risks, and enhance maintenance efficiency. Sustainable robotics. The industry will prioritize eco-friendly designs and energy-efficient systems to align with global sustainability goals. Conclusion. The projected growth in the aerospace workforce by 2025 will serve as a catalyst for transformation across engineering, manufacturing, and robotics industries. Companies will need to adapt their workforce strategies, invest in advanced technologies, and enhance supply chain resilience to thrive in a competitive landscape. As innovations in robotics and automation continue to unfold, industries will find new opportunities for operational efficiency and growth, paving the way for a more sustainable future.